In the past 6 videos, what you saw were simple examples designed to illustrate the basic idea that underlays each one of these concepts. Here we're going to do some practice problems and put them all together. Usually the most difficult part of any sort of math, but particularly with probability and combinations, is identifying exactly which strategy you're supposed to use under which situation. So here we go. Letter A, there are 10 questions on a multiple choice test. Each question has 4 possible answers. How many different ways can the test be completed? So we could think about this similar to a secret code. There are 5, 6, 7, 8, 9, 10 different ways, or 10 different questions on this test with 1, 2, 3, 4 possible answers, and it's totally fine to answer A, or B. We could repeat anything, and we could do A would be different than BA. So in short, what we end up doing here is 4 possibilities raised to the 10 different times that those 4 possibilities can happen. So this one is akin to the secret codes. For letter B, how many 3-letter words can be formed from the letters L, M, N, O, P if repetition of a letter is allowed? How many 3-letter codes? So they don't have to be comprehensible words. So we have 5 total letters, 3 that we're going to choose, and we are going to allow for repetition. So that is 5 choose 3, or 5 permutation of 3, which is the same as 5 factorial over 5 minus 3 factorial, or 25, 120 divided by 2, which I think would be 60. Okay. How many lines can connect 6 points? No 3 of which are collinear. What is N? What is R? Geez, that is not immediately obvious. No 3 are collinear. So 1, 2, 3, 4, 5, 6, I think would be a good example. And how many different ways can I connect those dots? What we got? 1, 2, 3, 4, 5. 1, 2, 3, 4, but not going to recount that one. Oops. 1, 2, 3, 1, 2, and 1. So that seems to me like we're just going to use the fundamental counting principle, 6 factorial. Okay. What is N? What is R? I'm going to leave that outside the scope of this video. Letter D. In how many different ways can the names of 11 players on a football team be listed in a column on a roster? So how many different ways can I list 11 players on a football team? And I think that would just be 11 factorial. Because I could put here's my roster, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So in the first spot, there's 11 possible names that can go here. But then once we put somebody in the first spot, there's now only 10 possible names that can go in the second spot. Now we've removed 2, so in the third spot, there's only 9 possible names. So the number of different ways we could order them should be 11 times 10 times 9 times 8, or 11 factorial. And next problem here. E, how many different arrangements are there of the letters in the word bedazzled? Assuming, of course, that we are not going to repeat any letters. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9 total ways we could order those, but then we want to divide out all of the repeated letters. So it looks like E is repeated twice, so that's 2 factorial. And it looks like D is repeated twice, so divide out 2 factorial. And it looks like Z will be repeated twice, so divide out 2 factorial. And you can go to a calculator and find out exactly what that is. So the challenge with permutations and combinations and probability in general will be figuring out exactly which one of these strategies you're learning should be applied and how they interact in situations where you need to use more than one. And that really only comes with practice.